Okay, which ones did you find were true? How about this second one? The antiderivative, the most general antiderivative of 1 over x is natural log x plus c. Well, let's take the derivative with respect to x of natural log of x plus c. The derivative of natural log x is 1 over x, remember, plus the derivative of c is 0. So I do get 1 over x. I do get this 1 over x. They match. Took the derivative of the right-hand side. I got the function that I'm anti-differentiating on the left. This is true. Now, a lot of books will, in their rule list, say the indefinite integral, or most general antiderivative of 1 over x dx, is natural log absolute value of x plus c. You cannot take the natural log of a negative, okay? So that's part of the reason why that's in there. We'll talk more about that later, probably. Okay. How about this one? Antiderivative of 3. Well, is it 3x plus c? Let's take the derivative with respect to x of 3x plus c. Derivative of 3x is what? 3. Derivative of c is 0. I get 3. That's what I had here. That's true. Remember, this symbol means a function that you can differentiate to get whatever's right here. And it's not just any function, it has to be the most general function. You've got to have a plus c there, because there are infinitely many functions you can usually anti-differentiate to get this. They all differ by a constant. That symbol's called the indefinite integral symbol. And by the term indefinite integration, we mean anti-differentiation. Given the derivative, find the function. Okay, let's check this one. I'm running out of room here to check. How about derivative with respect to x of 1/3 5x plus 1 cubed plus a constant? Let's check that and see if we get 5x plus 1 squared. 1/3 comes out front. Power rule. Chain rule says I've got to multiply by the derivative of the inside. Plus derivative of c is 0. So I get 5x, the 1/3 times the 3 is just 1. 5x plus 1 squared times 5. So I get 5 times 5x plus 1 squared. Does this match this? No, I've got an extra 5. So this one is false. Now, if you think about it, what do you think that the correct answer really is? What do you think the correct answer for this really is? If this answer was 5 times too much, then I'm going to have to what? Make an adjustment, aren't I? How about multiply what I thought the answer was, or what was posed. Here was what was posed as the answer up here. But when I differentiated, I got what? I got 5 times too much. Got this extra 5 sitting here. So wouldn't it make sense just to take a fifth and maybe 1 over 15th times 5x plus 1 cubed plus c would be my correct answer? And if you take the derivative of this 1 over 15 times 5x plus 1 cubed plus c, you really will get 5x plus 1 squared. We'll learn a more efficient way of doing that very soon. It'll be called a method of anti-differentiation called U-substitution, and it's undoing the chain rule. Okay? You don't have to exactly follow what I just did, except because we'll learn a method for doing that. But what's important to realize is that this fourth statement is false, because when I took the derivative of what I was given here, it did not match what sat in here in the middle of this anti-differentiation sign. Okay, quickly, how about this one? Antiderivative of cosine x is sine x plus a constant. That's true, right? I know if I take the derivative of sine x plus a constant, I do get cosine x. How about this one? Derivative with respect to x of sine 3x plus c. Derivative of sine is cosine, but I got to multiply by the derivative of 3x, and I get 3 cosine 3x, but I'm supposed to get what? I'm supposed to get cosine of 3x. What did I get? 3 cosine 3x. This is false. How about this one? Antiderivative of e to the x is e to the x plus c. That's true, because the derivative with respect to x of e to the x plus c is e to the x. And finally, you can check and see this last one is false, because derivative with respect to x of e to the 3x plus a constant is e to the 3x times 3. Remember, you got to multiply by the derivative of the 3x. That's chain rule. Equals 3e to the 3x. So we had 3 false and 5 true.